You guys ready to talk today? Today's a pretty good topic. Are you guys ready for today?
Ready. I'm ready.
Okay, yeah.
I'm not
way,
ready.
If you guys don't know,
I'm just ready. We're going to start anyway.
Anyways, sorry. Today we are talking about Fil-C, the memory safe C. Is it useful? Is it good? Is it the future of C? As always, we have with us Tej, creator of a C-based memory course on boot.dev, where you get to go over how a language... What was that, TJ?
Good point. Yes, great point.
Okay, well, don't interrupt me saying that. I'm like in the middle of a really strong intro. All right, anyways. As always, we have with us Tej DV, creator of a C-based memory course on boot.dev, where you go over how to create a garbage collector, and Casey Muratori, legendary C-Chat game programmer. Check out computerenhance.com for his amazing courses and lecture. And we also have a special guest with us today, low-level security extraordinaire, and also C and ASan Chad. Check out lowlevel.academy for amazing courses and all your low-level needs. Hey, no problem, buddy. So now let's talk a little bit about Fil-C.
Ed gets to say a comment, and it didn't break the intro.
I'm the last one. Suck it, nerd.
He said it cleanly. He said it cleanly. Yeah. He got it in there, Tej. It was like part of the flow.
Okay, all right. My
part of the flow.
Talking, TJ, right? And you just were like, hey, that's a great point.
I didn't even think about how that would be relevant to this today. So I was surprised. Go ahead, Brian.
Anyways, just for everybody to understand a little bit about Fil-C, here's some basic C code along with a special standard fill up at the top that's brought in that allows a special kind of printing character called the capital P. And in there, it will actually print out, hey, look at this. This pointer actually has 3 values in it. You, the C developer, will only see just, the integer. But underneath the hood, there's actually some extra information stored. And this actually shows its lower and its upper bound. You can see that we allocated 16 bytes. And of course, there's 16 bytes difference between the lower and the upper. That is fantastic. And with that, it allows for some special behavior. So here we go. We malloc 16 bytes again. I attempt to access byte 42, or technically the 42nd index into here, which would be out of bounds. And Fil-C says, ha, 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 ha. I've thwarted such an easy and very obvious thing. Now, some of the things about Fil-C that makes it a little bit unique and probably is going to make a lot of people mad is it's actually garbage collected. That's right. It's a C that is garbage collected. So if you look underneath the hood, even if you call free, it does not technically free it. It marks it as being freed, and then later on, the asynchronous, multi-threaded, behind-the-scenes garbage collector will go and free that memory. So it's a very this is not your grandfather's C, okay? This is modern C. And which means
whatever, that's fine.
Good one, TJ.
I'm just saying he made one. It's fine. It's okay. Keep going. They have garbage collector in C for a while, but yeah, that's okay. Go ahead.
Yeah, I know, but that's not like your standard operation in C. People don't think C. Oh yeah, that garbage collected language. Like that's not the first thought that comes into people's heads. Whereas this is garbage collection at all times.
Yeah, standard C does not have a garbage collector.
Yes.
That
is
true.
If you're right, you're talking about some additional thing when you talk about C garbage collection, right?
Yes. Whereas this is going to be like your standard experience is actually garbage collected. Now, obviously, Fil-C does come with a lot of performance penalties and runtime checking. Like when I did that little check into P42, it obviously did a runtime check on that. When you attempt to run it, it crashes your program successfully. And so that is a yes, TJ?
I was wondering, do we have any bouncing balls to show the performance penalty for charts? Because I feel like as you said performance penalties, I literally wanted to slap myself in the face that I did not bring a bouncing ball chart to benchmark this for Casey. I'm so angry. I'm so angry.
As you can see from this diagram.
Right. Very scientific. That
there are some performance penalties. It's like, no, actually, I can't see from that diagram because the diagram sucks. That's why I can't see it from that diagram.
That's pretty funny. Look at all these engineers sitting at their neat little desks. It takes dirty work to keep a code base clean. Every day, sickos are out there committing unreviewed code. And when that happens, linters won't save you. You need someone like me.
Let's go!
Feature-free scrumbag.
Who are you calling scrumbag?
What's this slop you're trying to push? Unnecessary comments? Global state? Nested ternaries?
Oh, my bad. I didn't even read the code yet.
You disgust me. Step away from the keyboard.
Just let me explain.
Is that a mouse? He's marching a prod! You have the right to remain silent. Anything you push to GitHub canon will be used against you. You have the right to a debugger, but if you cannot afford one, a public stack trace will be made available to you.
And one more code criminal off the streets where they belong. HR.
Look, I know I didn't review any of the code, but I was gonna have Code Rabbit review it from the start. With one-click fixes and style enforcement, I don't need Merge Cop. I would never merge unreviewed code, but a first pass with Code Rabbit always makes things go faster. Actually, you can try it too at coderabbit.ai.
Next week on Merge Cop.
The Diffler's out there, and I'm gonna be the one to deprecate him.
So to kind of wrap it all up so everybody understands how Fil-C works, the runtime impact of Fil-C is going to be somewhere between 1.2 to 4x is what I have seen. And then you will see comments on the internet that say something along the lines of, what's 20% these days? Nobody cares if you lose 20% performance, which I know that Casey will probably lose some sort of sleeper hair over with that kind of comments on the internet.
Wait, how did we get from 1 to 4x and go from that to 20%?
Well, because 1.2 would be, 20%, but then the 4x
you mean
would be,
if you just took just the minimum as assuming that you were gonna get the minimum for some reason without evidence. Okay, sure.
Can I say there is another performance penalty? Can we talk about that really quickly as well?
Yeah.
But
What's the
before
other
I do that,
performance penalty?
I just have to. I'm gonna be a little bit on the Rust side today, so I came prepared.
Oh no. Perfect.
Okay.
Hey guys, it's Rustige checking in today. The other problem is that there's a serious memory additional performance constraint here in the sense that it's going to allocate a lot more memory for lots of different kinds of programs. So I just wanted to make sure that that's clear. It's not a zero cost abstraction. Okay, it's not a zero cost. So Prime, you may continue.
Actually, TJ is very, very correct. It is not, in fact, a zero-cost abstraction. Anyway, so I just wanted to talk about this because the thing that really sparked all of this was that sudo rs is kind of this new brand of sudo. It's the new sudo on the block, and Ubuntu is saying, hey, we're using it, but all the comments are like, why? Why are you doing? Like, it seems to be at least it appears, I don't know if it's actually true in real life, but in Twitter life, it appears to be a largely negative experience. And so with that in mind, some people are saying, well, why don't you just use Fil-C? The performance of sudo is negligible, and you can get 90% of the safety without having to deal with Rust and a rewrite and rediscovering all the bugs. And so that's why we have with us Casey and low-level learning. TJ is just here for fun. And so therefore, I think it'd be fun to start probably with the security side, just because I think that is probably the most poignant, or at least the most reasonable place to start when it comes to a memory safe C. Ed, if you'd like to kick off any talks about that, I have a lot of questions about it, but any initial statements?
Yeah, I mean, so I guess to kind of kick this conversation off, right, what is spawning this? If you guys aren't aware, sudo, well-known, well-loved program that tends to be the target of a lot of vulnerability research because it is one of the most widely available, widely used set UID binaries, right? It's a binary that runs as root, and you use it to run things either as root or somebody else. And so a memory corruption vulnerability in sudo obviously violates a pretty hefty, pretty scary security boundary. And so as a result, there's a push to rewrite a lot of bin utils, one of them being sudo, in Rust, right? Kind of a cool idea. This also, for some reason, kicked off an effort to rewrite all of the core utils in Rust to include echo, cat, sed, which is a whole other conversation. But unfortunately, despite it being written in Rust, shocking, I know, I think there were 2 CVEs that came out recently in the RS implementation of sudo. So it kind of begs this bigger question, and I think, we've talked about this in the previous episode that I was on with Casey. All because you write it in Rust doesn't mean that you're going to get the exact same behavior. And if you can't confirm via some set of testing that you have, not regressed at all in your functionality, then you're potentially introducing new vulnerabilities to the code through logic errors. And that's, I think, exactly what we saw with sudo rs. So instead of rewriting everything in $new lang, and I'm sure we're going to iterate on new lang every 20 years, why not drop in a new compiler that has sanitizers, that has intermediate representation checks to put in on an arbitrary pointer the vector size, right? And that's what Fil-C does. And I have not used Fil-C personally. I'm kind of curious, Prime, how it went for you. But overall, I think Fil-C is a great idea. There are some compat issues. You have to be compatible with the LLVM toolchain to make it work, which is kind of an issue for some pieces of software. But generally, great idea. I love the concept. So that's kind of my first take. Casey, what about you?
I'm on the same page. Essentially, like rewriting something in Rust to me is usually a pretty bad idea because the problem is that Rust can only guarantee you a couple security things that it's specifically designed to do, but all of the other ways you can have bugs are still there. So it doesn't really handle all of like your logic errors or things like that could result in your program doing something potentially catastrophic, especially in the case of like a core utility like sudo. And so really, like, I would never have, I would be like, don't do that. like we know that there are memory, safety problems in the languages these were written in, but they've been kind of beaten out over the years, and we can keep looking for them and so on. And so rewriting something in Rust like that is just very dangerous and I think ill-advised. So something like Fil-C is kind of a very nice middle ground, I would say, which is that like we can preserve the logic integrity of this thing that has now been battle tested so that we're pretty sure that we've found a lot of the logic errors that I'm sure were in there originally that we've now kind of gotten out over the years as people found them. But now you can also get this added layer of memory checking just to make sure that memory things we haven't found yet, maybe this will protect against those. And then you're really just down to like, okay, are there bugs in Fil-C itself, right? And, maybe those take a little while to suss out too. Like maybe there are some edge cases that, will be found. But until then, it's like that seems like a much better, that would be true of Rust as well, right? Like there's no difference between Rust and Fil-C in that sense. You can always have bugs in the implementation of the memory safety. So it really does seem like a much more sensible approach. If you're just talking about our goal here is to make sure that we're providing the safest possible version of something like sudo. Yeah.
Okay, so I mean, those are all kind of like they feel like intellectual arguments more than actual like practical arguments. Do you think there's an actual practical argument to saying that Fil-C is going to be something that is like fully usable? Like Casey, could you use Fil-C in a game, or would you even ever consider using something like Fil-C in a game engine/game?
Well, I mean, you'd have to have some reason why you felt like what it's offering you is important. So, there are some ways in which you could imagine this being important. For example, if you have a lot of user-generated content in a game where potential bad actors might be trying to use that ability to upload content to create sort of security exploits, right? You can imagine something like Roblox or Fortnite or whatever, where they're kind of constantly trying to increase the amount to which their users can contribute new games, new modes of play, whatever. You could imagine something like that where there are cases where you're very scared about things like memory protection and stuff like that. And so I could see maybe some arguments in certain specific scenarios where you're like, we really need this, so we're going to take this isolated part of the engine and maybe we will use something like Fil-C. We'll accept the performance hit, but we just really need this. We need all the security we can get. But for the majority where you're talking about just running a game in an isolated context on someone's machine, it's unclear what you really need this for, right? For the average game development, it's not really, and I mean, the person who created Fil-C works at Epic, right? They are working on, I think they work on Verse, the Epic, like Epic's Fortnite programming language thing. And so like, that I would imagine most of like an Unreal Engine or something like that wouldn't really adopt something like Fil-C, but you could see some specific cases where that might be important. And for example, Verse, which is their language, that would be a case where he probably is employing some of these techniques there. I don't have any inside knowledge of that, and I don't work on that, but so that'd be my take on it. You'd have to be in an area where you really cared about it, because otherwise I'm not really sure what you would need it for. Does that make sense?
Yes, I think that does make sense. I mean, where my big misunderstanding probably just comes from is that I don't understand. I was trying to read some of the things with the differences between like ASan and UBSan and how how Fil-C actually can circumvent some of those problems. But at the end of the day, TJ brought up really good points because he's being the resident Rust dev. there are things that Fil-C just can't do, and they even shouted out, which is like file handles. They are something that can't be represented in the same kind of context. Or
Well, here I'll give the example.
Yeah.
First off, that's probably the longest a Rust user has ever gone without speaking. So I just would like that to go into the record as a moment for allowing other people to speak. I do have Rust running in production right now. So that is something that also most Rust users have never done. So I would put myself ahead of almost every Rust user in the entire world.
Hey, same guy. Listen.
Yeah. So just throwing it out there as two things that make me very qualified to talk about this.
But I do want to. I need to say one thing though. You also did the 0 to I use Rust, by the way, at the same standard rate as any Rust dev who starts speaking. Within the first 5 seconds, you mentioned the fact that you used Rust.
By the way.
By the way.
I thought I wasn't allowed to run Rust C unless I did that. I still need to run Rust C sometimes, so I don't understand. So, okay, anyways. So this is on a serious note instead of memeing about Rust users. This is not a reason that I would rewrite a program. So this is like a different class of things. So if we want to start, we can maybe talk more about the rewrite situation first, and then talk about if you were starting off a new project, which one you might want to choose and pros and cons. Because the thing that I think a lot of people are missing, and Ed and Casey, you guys both alluded to this at the beginning. Maybe I have to take my Rust hat off for this to say something nice about Fil-C. Is you can't just rewrite everything. Yeah. It actually doesn't work. We don't have enough time or resources or a bunch of other things. Even just if you think you can bug for bug remake it exactly right and handle every case, it's just not realistic to make that happen. I think probably I could run NeoVim, at even at Fil-C's current worst case, 4x slower, and NeoVim would still feel fast and good for me, right? You know what I'm saying? Even if it was four times slower. And that's assuming, and I see as well, we've got Pislinator in the chat, who is the creator of Fil-C, by the way. Fil-C is gonna, I think, get faster than what it is right now, as tends to happen for people who actually care about software and making excellent things. So it's I could run NeoVim, and then I would not be able to be exploited by certain cases of memory safe through bugs, right? Because I'm sometimes running slightly untrusted things in NeoVim. I'm running someone else's code, running via a plugin or other things like that. So it's not realistic to just say NeoVim, just rewrite in Rust. Just do it. It'll be easy. That's insane behavior. That's not a realistic scenario. So that's the thing. For some reason, I feel a bunch of Rust people are just talking past it of you could just have a safer world today. In fact, Graydon Hoare, creator of Rust, said more memory safe programs is better for all of humanity, right? In talking about Fil-C. So, anyways. Yeah.
This may kind of be jumping backwards in the conversation a little bit there, but
Right.
Prime, I kind of heard you, I think, sort of raise the question. You said, I have questions about, what's the difference between, address sanitizer and using something like Fil-C, right?
Yeah.
And I thought maybe that might be something that's worth talking about a little bit.
Yes. Because
Okay.
I've ASan'd a few times in my life. I'm no ASan
Okay.
expert, and so I just know that it has caught. I've done silly things with standard vector in the old C++ world where they're just yo, you're doing stupid things, and I was oh, that is a stupid thing. I just didn't know I was doing it.
Right. So just to be clear, the idea behind things like Fil-C, and also just there's kind of a broader security idea here actually than just Fil-C, which is that ARM chips, or the ARM specification I should say, and certain vendors supply actual hardware support for the kinds of things that Fil-C does. It's not exactly the same as Fil-C does things beyond what this hardware would be doing for you, and we can talk about that a little bit. X64 spec also has now introduced this, although I guess I haven't really followed closely enough whether anyone's shipped any of it yet. But there is a specification for it, right? And so I'm assuming that Xeons and Epic processors down the line will have this for servers or something, right? I haven't followed out the uptake. But Apple M series chips now, for example, do implement this particular ARM extension. Anyway, these things are not designed to analyze your program when you're developing it and tell you whether they found security vulnerabilities. They're designed to actually just stop the program anytime it's running when it would have done something bad. So the idea here is to make sure that something that address sanitizer maybe wouldn't catch because when you were running the program, you never exercised the code path that happens to do this thing, or whatever else, like the static analysis part can't catch things, or whatever you were using. This is designed to basically say, look, the actual runtime model of this thing literally can't do these bugs. Yeah. When they would have happened, the program simply halts. It's basically just a thing that says when you would have written to a piece of memory that was actually a different piece than this pointer was supposed to ever be able to write to, we just stop. The program faults and it closes.
Yeah.
And so again, it doesn't really prevent the bug in the sense of the program working. The program still doesn't work. What it does is it stops it from turning into anything other than basically a denial of service attack, right? So does that make just light sense just to start with?
Yeah.
Yeah, there's a lot of talk in chat right now about ASan. We should probably highlight. Like, ASan, for example, is not meant to be an exploit mitigation in the sense that you use ASan to block hackers, right? Because all ASan does is put a predictable pattern as a shadow region in a memory space so that when that is corrupted, it's like, hey, it's not the same, you probably should fix this. But the pattern that it puts is probably is deterministic, right? So like an attacker could just put the FAs in the right spot, and that would not trigger ASan while still violating memory safety. So ASan is more like a tool that you compile your code with to make it as fall over as fast as possible to put it in your fuzzing rig in CI, right? So that in 2 weeks when your fuzzing is done, it hopefully has crashed at some point if there's a bug. Contrary to Casey's like the Fil-C thing, which is let's, instead of having ASan just kill it, let's put in like intermediate representation logic within LLVM that says like, hey, we're going to assign lengths and things to C arrays such that you are not allowed to program in memory or memory unsafety. So it's kind of two different schools of thought on like sanitization versus runtime, if that makes sense.
And for people who don't know, because like a lot of people probably haven't written like systems level code, like maybe Ed, you can just give a really brief overview of like how that memory unsafety leads to bad things happening on someone's computer. Because I feel like a lot of people, they just literally don't even know what's going on there.
Yeah, 100%. I mean, so like the crux of every memory exploit boils down to this pattern, okay? Let's take an array, and we want to index into that array using the index I, right? Okay. Now let's, instead of that I being a number that we program into our code statically, we read I off of the network, and we're using some type length value network protocol where we have like the type of a field, the length of a field, and then the number of, or the length of the field and then the data, right? Most of the time, it just happens that, oops, the developer forgot to validate that I is within the scope of that array, and so you get an arbitrary read, arbitrary write. And that ability to arbitrarily read and write data gives you ASLR bypass, it gives you stack canary bypass, it gives you the ability to overwrite relocatables so you can redirect program control to somewhere else. And that is the crux of almost 80% of memory corruption bugs, right? There's some other ones that are a little more weird. So if you literally just create proper bounds in a language that is memory unsafe that disallow a user to write outside of their confines, that solves the problem. And so Fil-C, again, I haven't used it, I haven't explored too much into it. What I understand is that Fil-C uses LLVM IR to say like, oh, you've made an array that is 64 bytes. I'm going to put, you basically turn all arrays into vectors and then do runtime checks on the vector before you do writes. And like, oh, if you violate that, you can't continue. And so that stops most bug classes. I think Casey was talking.
Like I say, it's more hardcore than that. Like Fil-C is like kind of like if you're someone who is 100% at the Rust party ladling out the
like
Rust
me.
Kool-Aid. Yeah. Into the little Rust cups that you hand out and go like, let's do this, let's drink this, guys. Then you should love Fil-C because it takes it way more seriously even. So essentially the way that Fil-C is designed to work is it's a lot like the hardware extensions, only instead of trying to be relatively transparent, it's saying, look, we're going to incur a cost. And so what it actually does is it tracks essentially all allocated objects of any kind. So anytime you actually do any kind of allocation, it's going to say, all right, I'm going to track that in using, what you would call like memory outside of the addressable space of your language, meaning inside what doing what you're able to do inside a Fil-C program, you cannot access the tracking data, if that makes sense, right? And so that tracking data will then be used anytime you're trying to work with one of these pointers, like a regular C pointer. To you, it looks like you're working with the pointer normally like you would in C, but actually, Fil-C is going to look to make sure that that pointer originated from the actual part of memory that you are accessing, right? So it tracks not just are you in bounds, meaning not just are you within the particular object that you that you sort of claimed you were accessing, but are you in the one that this pointer originally came from? And this works even if you like read and write pointers to like blind memory and stuff like this, right? Because because essentially what Fil-C is doing is it's using sort of almost like a pseudo pointer. It's using a 64-bit value that you don't directly use. You indirectly use it by looking at sort of that tracking information to make sure that you're tagged, like that you like match what you're trying to access. And so when they do this in hardware, it's a sort of a weaker version of this. What they do is for pointers in the hardware versions of this, they just use the top bits of the pointer that wouldn't be used because you don't have that much memory. You don't have 64 bits worth of memory in a machine. They use the top bits to assign, say, like a 4-bit tag, a value between 1 and 15, let's say, and 0 is usually reserved, that sort of stuff. They'll use that tag, and then every block of memory that you sort of allocate, or rather that you mark, you can say like this region of memory, you can mark regions of memory with tags, whatever you want, some random tag that you associate. Every time you use a pointer to access some memory, it checks to see whether the tags match. So that even if 2 blocks of memory are right next to each other, if you go from one to the other by incrementing the pointer, like Low Level was saying, if you go outside of like an array bound, the tags hopefully won't match because hopefully any 2 neighboring regions got different tags, right? But that's really like, there's some other things that you can use that these extensions do, but for the most part, it's doing that sort of thing. And Fil-C is just sort of like the on steroids version of that, right? It tracks everything about these so that you can't even have accidental conflicts of the tags. It's not just using some simple like 4-bit scheme. And it also does like more aggressive use after free tracking and all this other sorts of stuff by using garbage collection to like never remove those things so that it remembers like each region until it's actually not accessible by anyone anymore and so on. So hopefully that's just a little bit like, so it's a much more complete system than something like address sanitizer, if that makes sense.
So
that's a lot of stuff in there, but
yeah.
Is it effectively turning all memory accesses into like a virtual pointer where like,
yes,
it's like a lookup into another object table and then it does access. Bounds check.
That's probably not that's lower. Probably, it sounds a little bit more, that might be a slightly more aggressive way to say it. You can think of it more like, there's almost like a shadow version of thing. You should go take a look. They have a very nice page which has the something. Yeah,
Ed, I'll show you, but I have to power up first.
Oh, Jesus Christ! Where do you have all these images from? Why?
Okay,
that's pretty good.
Now I'm Super Saiyan mode because we have a whiteboard. Okay,
Super Saiyan Rust user. I like it.
Yeah. Okay. So in this case, right, we have like pointer X. It's pointing to 40. Right. Y 44. Right. You can imagine in memory, we've got these 2 pointers, right? What happens in normal C when you access like X5?
Yeah, you just get 0 or whatever like the next if element is. Yeah,
we get over here.
Yeah.
But in Fil-C, it says, this, if we did like malloc 4 and malloc 4 for both of these, right? In this case, it's going to say it's got a lower bound, a 40, and an upper bound, a 43.
Yeah.
And here's where it currently is.
No, I understand that. I'm more curious about the implementation, right? Like, in the context of this example,
like,
what is X? Is X a pointer to a thing, or is X a lookup into a shadow? Yeah.
X is
the
just
X to you, the user, is still just this pointer.
Interesting.
But I'm assuming this is what maybe we can get confirmation. As far as I could tell from reading and everything else, it gives you back exactly this. This is what you think you've got. I think it's wider. So
I don't think that's how it works.
it's
and it's
16
not wider.
bytes wide, though, right?
No,
So
no,
it's
no,
wider.
No. It's the
8
same
bytes.
size. It's 64 bits.
Oh, it is. Okay, it's still
Yeah,
the same size.
It's
I
transparent.
don't use Fil-C, and the first time I heard about Fil-C was when you guys said we were doing an episode about Fil-C.
Nice,
So
okay.
I apologize for not knowing more about it. If I was a Fil-C user, I'd be happy to get the full explanation. I believe the way that it works is they use a shadow allocation. So every time you allocate something, they allocate twice that, effectively, right?
Yes, you're right. You're right, Casey.
And then they use so effectively what X is it's going into the shadow region, which then tells Fil-C where, like, how to get the additional data. In fact, you said the person who wrote it was in chat. Is that a correct? Would that be a good
64-bit
summary?
pointer.
Because I read
Yes,
about
Casey.
this literally yesterday, so
Yeah,
that's
I know.
all
Yeah.
I know. But that, I believe, was how it was explained in the documentation.
Yes, I think you're right, Casey. Yes,
Okay.
yeah, that was my apologies. It doesn't return the
Yeah.
wider one. It has one somewhere else that it's holding onto.
Yes.
That tells
it's
you.
called invisicaps, right? It
Yeah.
has the invisible capabilities stored off in a region in which you're not allowed to access, in which the thing
Exactly.
returned to you looks just like a pointer, acts like a pointer, smells like a pointer, and in C, it's just literally a number, and then boom, bada
Right.
bing, it does the runtime checks against it.
Right.
And
So,
that's
but
why
the-
you can
the-
still add to it and work with it like you normally would, because they have a shadow region, they can still, like, figure out, like, what's going on there, right, or things like this. And so I don't know the specifics. I want to now read more about it because I thought it was really cool when I was reading. I was like, oh, this is a really neat thing. So I'd like to go read about how they handle all the actual practical details, but I didn't immediately find sort of the document of that. Like, there's really good overview documents, but, like, oh, how did you handle this? How did you handle that? Like, I didn't find that immediately. So I'd like to go read, like, how do you actually use the shadow region? Like, how is it doing that? And all that sort of stuff. And also, the other important thing that they bring up in this documentation, which I think is important to mention as well, is that if like a naive implementation of stuff like this would have a lot of problems with threading potentially, because, like, different people can sort of mutate pointers and and you can have race conditions, this sort of stuff. And so Fil-C is also very careful to make sure that they get those things right, which, again, like, if you look at it, it's like, wow, this sounds very complicated. Like, why does it have to allocate all this extra memory or things like that? And the answer is because they were trying to take this really seriously. Like, not like, oh, we caught some memory bugs, but, like, no, we really do provide a secure operating model, which again, if you're drinking the Rust Kool-Aid, you have to respect that. This is doing it for real and on existing programs. It's pretty great. Yeah.
Yes, we like that. That's the crazy thing for the Rust people. Even with my Rust super crazy hair on right now, that I don't really get is, like, this is good. This stops this from happening. Right now, if you ran C code and you did this, it would be chill. You're like, it would be chill. It would let you just read from memory. That's not the thing that you're doing. That's bad. We don't like that. We want computers to work good. Like, that's the thing that I don't get. So that part's good. And it seems like for some reason everyone's mad about it, and I don't really get why they're mad. I don't know. Maybe it's
because it's good. Most people really hate it when you introduce something good that's not the thing that they were previously telling everyone was good, right? Like they don't like to hear that someone else made something good that might be a reason not to use their good thing.
That's true.
Right? Like heaven forbid, right? But yeah, I do have one question about Fil-C that I wasn't able to answer directly from my sort of 5-second read. So again, like, it'd be nice to maybe if the author is in chat, maybe they can come on sometime and tell us so that people can have a more accurate description of what it's actually doing, because that would be really nice. And obviously they would not get it wrong because they wrote it. But what I was going to say is, I don't really know how this works with things like, okay, I create a block of memory that I'm going to sub-allocate out of, and I wasn't sure, like, what it does for that. Like, that's one thing that's, like, on my list now. I'd like to go read about, like, how it deals with that. And like, is that just disallowed? Is it allowed? And we just say, oh, well, it
no
doesn't
sub
catch
capabilities
problems.
right now.
What?
No sub capabilities right now. I assume
Okay.
that's because if you take a pointer from that region, you technically have a lower bound of the original lower and an
Exactly.
upper bound of the
Yeah.
of the big upper. So
Yeah. And so like, that's a thing that makes it kind of hard to port a lot of existing programs, because a lot of them will do that, right? And so then it's kind of like, okay, those programs kind of have to be rewritten to like maybe there's some way that, you know, Fil-C could be extended to support that. Like, hey, allow us to sort of write a section that's like, here's how the memory marking is going to work inside our thing. I don't know, but like that would make it challenging to port programs that were written in that style, which is a very good style of writing. Like, it's very efficient, and so it's kind of I don't know what you do about that if it's, you know, in terms of I want to use this in some subset and I want to just use my existing C code.
Effectively, the creator, Piz, is saying the best thing you can do with your arena allocators is to replace them with individual mallocs.
Okay. I mean, which is not that hard because usually your arena allocations are going through like a pound define kind of a thing to like allow you to switch them for debug and stuff like that anyway, or to mark like where they're coming from. It's fine that bet. And I guess let me ask another question while we have the benefit of the author in chat. So do you then just like because normally arena frees are just going to free the whole arena. So is that just taken care of by the garbage collector?
They said
then?
don't call free, let the GSP deal with it.
Cool.
Then that's not a hard port.
Yeah.
Right. That's not a difficult port, I don't think, for most people, because like at least for my own code, I always have those running through a macro, so you can mark them with file inline and debug and stuff like that. So that seems pretty reasonable.
And if you've been following along, we'll link as well. Pizzlinator, your X in the like description of the episode, but like Pizzlinator's been working on a bunch of different like very complicated, very real world C programs that are big that you cannot just rewrite to Rust. Guys, you can't do it. And talking about like Emacs and Ruby and a few other ones, you can follow along as he's kind of like microblogging, as they say. That's in these days, right? Microblogging. I'm on Tumblr, obviously. You can tell from my hair. So you can follow along there for a bunch of different ones and see what he's been up to and how he's gotten there, which is cool.
All right, TJ, as the resident Rust expert,
yes, thank you.
Could you help us understand things that Fil-C doesn't do, or why?
Yes.
Like, why would you if you're starting brand new, but you're really good at C? Why would you even want to choose Rust if you want to type like or at this level of safety and you're like, well, I could just use Fil-C, but why would you want to choose Rust?
Yeah, a blue field project, if you will, for me.
Yes.
So
a blue sky project, Teach.
Blue sky, a blue sky project. If I was
field.
starting a new blue sky project today, what would I pick?
Yeah.
Okay, so one reason you wouldn't use Fil-C, you don't enjoy writing C. That's one reason.
Good
That's
answer.
a legit reason, okay? There's lots of projects that don't need to be written in C, okay? That's fine. In fact, there's lots of projects that don't need to be written in Rust. I almost have to take this off when I say this, right?
Yep.
It's just true. It's just true.
You lost your blue hair on that one.
I know. I get
I think you're gonna have to lose the wig, Teach. That was
yes.
You've been you've been removed from your board seat on the Rust Foundation for that. But okay.
Yes, but let's say you're starting out a new project, and the requirements are such that Rust makes, or some systems language makes a good choice, right? So, or you just have some other requirements. The example for me that like when I was working at SourceGraph, we have a very straightforward in and out system where we have text come in and we need syntax highlights to come out on the other side. It actually matters for that to be really fast. You want it to go really fast. It's always going to look the same shape. You have text come in. You'd like to copy it not so often. You're going to run this for like lots of different files and lots of different languages for lots of different customers. You'd like this to be really good and really nice and really, really fast. Okay, you have options for what you could do, right? You could write that service in C, I guess, right? It's a little bit harder to picture, but there are like decent like parser generators and other stuff you could use to get you part of the way there, and then you could apply some like syntax highlighting from that and all that good stuff. But now, if you're going to go and do something with Fil-C, you're going to experience a slowdown, and if you don't do that, you're more likely to experience some bad security vulnerabilities on a bunch of untrusted input because you're highlighting random people's code. Right, so they put in a Unicode character that was too wide for your thing and then overflowed this buffer, and now you access this. It's corrupted memory, and you screwed yourself over. Too bad, so sad. Right? So So in some cases like this, where you need a lot of speed, you're maybe going to work on a lot of untrusted input, you're connected to the internet, you're doing other stuff like that. Like I think there's good reasons why you might want to choose Rust, and you'd be able to get like faster performance or something like that with Rust. I mean, also I think you know, from a like technical standpoint, a lot of people appreciate some of the like type system guarantees you can get from Rust that Fil-C is not going to give you. You're hopefully now, like you won't in many cases have like an actual security vulnerability. You won't have a CVE from these kinds of problems, but it will crash like at runtime, which is good. That's objectively better. Also, Rust crashes at runtime for things too. That's also how it solves some problems. So that's not like if Rust accesses something outside and it's unchecked, that's just an expect or a panic, and then it will crash. Sweet, that's memory safe. We are happy. That's actually good. But like, there's lots of things. The example you had brought up earlier for like file descriptors, right? In Rust, if I open up a file and I am making my own, you know, like API for it, I'll have the file descriptor. Or I'll have the function take a callback. That callback's one of the parameters will be a reference to the file descriptor. In Rust, the borrow checker will prevent me at compile time from accessing that outside of the callback, right? So you couldn't like save the file descriptor to a global and then try and read from it later. That won't work, right? And most of the time it's like not clonable and not copyable. So you would have to go through like a lot of hoops to try and even get that value out in a way. You could even literally like just copy
it. The callback pattern
is
impossible in Rust. It's so hard to use. The callback pattern in Rust, it's so freaking tough.
True.
Yes.
I still haven't figured out streams quite successfully yet.
Yeah. But that would be a thing, right? That like if I try and use this value, this file descriptor, outside of the callback, the type system and the borrow checker, right, the linear type system that Rust has, will block you from being able to do that at compile time instead of like runtime, right? That's like, for me, I'm a type systems guy. I like types. For me, that makes me happy, right? Like, of course, especially with the blue hair on, that makes me really, really happy. So that would be something where like, if what you want to do, right, like push left, we're going to push the errors to happen earlier along in the dev cycle. We're going to experience those at the compiler, and there's no like 100,000 lines of battle tested code that has a bunch of stuff. You might choose Rust over like Fil-C, right? And then you like, and that would be, I think, a reasonable choice. But for me, everyone seems to be talking past each other about that on the internet, which is surprising.
Can I ask a clarifying question there? I'm not sure I 100% followed that. Yep. First of all, I would also say that the phrase push left strongly like sort of suggests a left to right reading language, because that's the order you're going in. So I think you lose the blue hair on that one as well. But
true.
Wait, don't you should say more towards the beginning of a sentence push is the correct way to say that.
Yeah, exactly.
What I would say is, what is the bug you're trying to prevent with this file handle scenario, just so I understand what you mean by Rust preventing this better than...
Like, if you have some function, right, that, like, opens up and then closes a file handle for you and says, like, hey, or a file descriptor, right, or any kind of this thing, database connection, any kind of thing where you have, like, a handle, right? If you're writing this in, like, this is not true of just C, but this would be, like, in Python or something, too. You could just, like, save that handle inside of your callback to some global value. It can escape its region, right? So if you, like, do with open file descriptor in Python, and then inside of there you, like, save the file descriptor, and later in your program, after that original thing's already closed it, you're outside of that region now, you try and read from it again, it'll be an error. It will crash. Right?
But I mean, that's pretty easy to implement in C or C++ as well, right? Like, especially C++. Like, to
do what part?
You just wrap file handles in an accessor, and that will just work, right? So like, if you wanted that protection in C, you could just get it, right? Like, you don't need a language.
Rust being defeated as we speak.
No, I mean, like, I'm not trying
to
diss on Rust. I'm just saying I don't understand why you couldn't just make that same thing by just making sure that instead of using like an int as your file descriptor, you actually use a struct that does something, you know, or you know, a C++ class for up-to-date programmers, right? Whatever.
But I'm saying, like, sort of regardless of that, I think we're not talking about the same. I'm saying, like, we could prevent in like Rust with the borrow checker, you can prevent the value from escaping its region, right? Which maybe there is a C++. I'm sure there is a C++ thing that can do that. I don't know. I just assume everything is possible.
You're just talking about like you want like because they have special cased file descriptors with the static analysis in Rust or something like this.
No, I think I'm
because you were talking about type system, and I'm like, well,
Yes.
the type system in both can do what you're talking about.
So
if we're just talking about the type system as opposed to other things, right?
Yes,
Or-
I'm just talking about the kinds of things like this is, as like I'm trying to present the case for why someone would say they would rather write this kind of thing in Rust, right? Is
Okay.
instead of experiencing a crash with Fil-C at runtime,
Okay.
we could find that out from the compiler. Right?
Okay.
That like, this kind of access isn't allowed. That's not thread safe, that escaped its region, but it shouldn't. This kind of value, right? Like there are things that we can do there, right, in like Rust with the type system that fight the same kinds of bugs you might get solved from Fil-C, right? But instead of having a crash at runtime, it doesn't compile, and I handle that case.
Yeah, the borrow checker defeats use after free and double free at compile time. That is the objective of the borrow checker.
Yes.
Yeah.
That's a probably way more succinct way to say that. Good job, Ed.
Got it.
I like to think of it as just like it's effectively a unique pointer, but at compile time.
Mm-hmm.
Right. So my point being, separately from, I think it's obviously good that there's an option where we can solve a bunch of these classes of bugs in C and prevent it, right? In this case of like which language would I pick for certain projects, there are definitely like reasons you would pick Rust over just picking Fil-C for like a new greenfield project. Of course, there's other reasons why you might pick C over Rust as well. Like you might actually ship it and things like that, which is cool. But that's like those kinds of bugs. Fil-C does not solve that at compile time. That's all I'm trying to say as like a comparison of the two. And that's like a reasonable trade-off that people want to make.
Yes, and that's
just
also
to be clear on that though. That's
from.
because of the borrow checker, not the type system, right? Just so we're clear on that part, right?
Yeah, I mean,
or just so I'm understanding it, I should say, right? Because that was the part that threw me. I was like, why is that a type system problem? Okay.
Actually.
Okay, so it is actually the type system.
Well, the borrow checker is sort of like a result of the linear affine type system that Rust has.
Okay.
And
I'm
so
too dumb for this conversation. I don't know what's going on.
I would just say
Okay.
they go together. You would like
Right. So you're talking about type system, the type system being like including the borrow checker.
Yes.
Okay, gotcha.
Yes, exactly.
That makes sense. So I also have another question, which is that does Rust catch all of the same memory errors that Fil-C does? Because I don't know if that's true.
No.
Fil-C might catch more.
It does.
Yeah.
That's the best
So that's
part.
like if you
But it
really
actually
care about
catches
security,
more,
you
right?
probably shouldn't be using Rust.
Yeah. Rust will
Right?
catch them, but like it'll turn the condition into a DOS. So it's like it's not an exploitable memory access, but it's also not caught at compile time. So like you can do.
No, I
that.
mean even at runtime. Does Fil-C catch things that Rust doesn't catch? Is my question.
At runtime,
I thought I saw a
don't think-
condition.
runtime.
I unfortunately forgot to save it, but it's a condition in which Fil-C does not catch something in which Rust does.
Okay.
I really
Inside
wish
of
I would have.
unsafe blocks, there are, I think, certain things you can do that in Rust, inside of unsafe blocks, that Rust does not check.
Real quick.
Even all of its stuff, and maybe still, I'm not actually 100% sure if it will do a CVE, but inside of unsafe blocks, that Fil-C does catch.
I
That's
do
my
have to go in 5
Syscall
minutes. I have a question for the
related
author
memory
real quick.
safety issues.
Yes,
is what-
go ahead.
Syscall related memory safety issues. Are you saying, for example, in a syscall handler where it does a copy to user, like outside of the bounds of a memory region? Like what about syscalls in particular? I'm curious what you're saying there, and then I do have to run. I'm sorry, guys. And we're gonna
I just
want to
say he said he did confirm CVE in unsafe blocks is totally possible.
He says
says
yes.
yes.
Okay, how would Fil-C detect that?
Yes, Piz, give us the 9 yards.
And then we'll have to just have Phil come on.
Yeah,
later,
100%.
I think, is
I'm
the
so
other-
curious.
is
I'm
the
so
other
curious.
thing.
That's
We'll
the
get
right
Phil
thing is to
back
have
on.
him on the show. If as long as he wants to come on. I mean,
He said yes.
okay, great.
yes.
Yes. Yes. There's also I do think. I'll just
Maybe
mention
that's
one
all
other thing.
syscalls, the abstraction
As the
layer.
Rust person, I'll just put this back on.
Oh.
Sometimes 20% slower or up to 4 times, and 1.5 to 2 times as much memory actually makes it not possible to do constrained hardware or like other stuff like that. We'll just literally make it so that it's just not possible to accept the performance hits because some places in the world performance still actually matters, and you can't just spin up 5,000 new Lambdas and pay $10 million in cloud costs. Okay, there you go.
You've just you're gonna summon DHH, dude. You're gonna summon him. He's gonna be like,
What
yes,
if he
we
just
can.
walked out?
He's like, yes, we can. We will spin up all of them.
No, he's against
It's
that.
also true. You got to be careful. You can technically spin up all of them. You just pay a lot of money.
Yep.
Yeah, we gotta have
like
that
I'm
on,
paying
man.
it.
Like, this is blowing my mind right now. He said that it intercepts all syscalls at the ABI layer, which makes sense.
Phil,
so
I know
thereby-
what we need. We need a slideshow with these examples, and we can work on it together. I'll message you after this on X, and we'll get this set up. And we'll come back with a slideshow with code examples, and then Ed, you can ask every single question you want.
I've been wanting to do this a lot ever since Trash did the TypeScript presentation. I've been wanting to do more presentations and then have us all interrupt the presentation and be like, but what about this? What about this? What about this? And that was such a fun time.
Yes.
All right.
Okay.
But I
well,
will
then
say,
let's end it right now.
Low
and
level's
we'll
gotta
save our
go.
questions
I have
till
to
I
later.
did want to say
I
one
love you
quick
all.
thing.
Oh, go ahead, Prime. Sorry.
I will say that every time I use a union in C, I get so happy and so sad at the same time because it does make me long and yearn for Rust. I will say that automatic tagged unions at the syntax level is just a thing of glory and beauty 100% of the time.
Yeah, but don't worry. In another 50 years, the C++ committee will finally get one working.
We're almost there, guys.
doesn't
Just
suck.
one more committee. One more version.
one-
One more,
first,
one more,
JavaScript
one more
or C++?
2,000-page revision, and they'll get to the discriminated
Okay.
unions working properly instead of sucking.
Casey,
Yeah.
if that were true, then why are some people using like C17 instead of C94? That doesn't even make sense then.
It
Checkmate.
doesn't make
Yeah,
sense.
go checkmate.
Because
Checkmate,
94 is
Casey.
bigger than 17, so we should be using that one, don't you think?
2094. Yeah.
Checkmate,
That's-
AC.
that's-
All right, I gotta go. Bye.
Better than
Bye.
C99. Sounds worse then, really.
Yeah.
All right, everybody, we'll go as well just because this is happening. Ed already left us, and now the stream is completely screwed up. Thank
true.
you, everybody, for joining us for this. Hey, if you are watching on YouTube, you can see everything on Spotify. You get the full episode because you miss a lot of the banter when you only watch it on YouTube. So thank you very much for watching. Thank you for all the guests. Ed with lowlevel.academy, Casey with computerenhance.com, and Tej with boot.dev/Tej. The
Yeah,
name,
or by the way.
or by the way,
ETW.
if you want to support both TJ and I, because I also have
True.
2 courses on there as well. I just did like
great
a
point.
Spider-Man thing, and the name is the Spider-Gen. All right, thank you, everybody.
Boot up today, vibe coding, errors on my screen, terminal coffee.